Chapter 2.8, Proving Angle Relationships. Just like we had segment addition, we also have angle addition. So looking at this picture here, if I add the measure of angle ABD plus the measure of angle DBC, I would have the measure of angle ABC. So measure of angle ABD plus measure of angle DBC would equal the measure of angle ABC. If two angles form a linear pair, then they are supplementary angles. The shorthand or abbreviation that we can use in a proof, or if we're asked to give a reason for something we've done, is just to write linear pair implies supplementary angles. If the non-common side of two adjacent angles form a right angle, then the angles are complementary. So our shorthand would be two adjacent angles. If they are a right angle, then they are complementary angles. Angles supplementary to the same angle or to congruent angles are congruent. So in this picture, if the measure of angle 1 plus the measure of angle 2 equals 180, in other words, they're supplementary, and the measure of angle 3 plus the measure of angle 2 are supplementary, so they equal 180 degrees. Well, angle 2 then is supplementary to both 1 and 3, so therefore angle 1 has to be congruent to angle 3. So angles supplement to the same angle, so there should be an E in there, same angle, or congruent angles implies that those angles are congruent. Looking at the same case of supplementary angles, if the measure of angle 4 plus the measure of angle 5 equals 90 degrees, so they're complementary, and the same with angle 6 and angle 5, then since angle 5 is congruent to both 4 and 6, we can say that angle 4 is congruent to angle 6. So angles complementary to the same angle or congruent angles implies that they're congruent. The last one we've used quite a bit already. We know that angle 1 and angle 3 are vertical angles, these two, so they're congruent. Well, so are angle 2 and angle 4 vertical angles, and they're congruent. So our shorthand for this is vertical angles are congruent. In this problem, we're told that the measure of angle 1, so this measure right here, is 50. We want to find the measure of angle 1. We don't know. And we're told that the measure of angle 2 is 56 degrees. And that the measure of JKL, this big angle here, is 145 degrees. Well, we know that angle 1 and angle 2 would add up to be angle JKL, so it would add up to be 145 degrees. So to solve this, we take 145, subtract 56, and we would have 89. So the measure of angle 1 equals 89 degrees. The next problem tells us that at 4 o'clock, the angle between the hour hand and the minute hand, these two hands right here, is 120 degrees. We're told the second hand bisects that angle, and bisects means it cuts it evenly in half. So we have two congruent angles. What are the measure of the angles between the minute and second hands and between the second and hour hands? Well, since it's bisected, it cuts it evenly in half, so it would be 60 degrees for each. The next problem tells us that angle 1 and angle 2 form a linear pair, so we know that they're supplementary. And by definition of supplementary, we know that their measures would add up to be 180 degrees. We are told that the measure of angle 2 is 115 degrees. So if we solve this equation here, we will know the measure of angle 1. So angle 1 is 65 degrees. In the next problem, we're told that angle 1 and angle 2 form a right angle, which tells us that they're complementary. And by definition of complementary, that means the measure of angle 1 plus the measure of angle 2 would equal 90 degrees. We're told that the measure of angle 2 equals 20 degrees. So solving for measure of angle 1, we have that it is 70 degrees. Now we're going to step back into doing proofs. The first step in a proof is always to write the given. Excuse me. So angle 1 and angle 4 form a linear pair. We're also told that the measure of angle 3 plus the measure of angle 1 equals 180 degrees. And this was our given. Well, if 1 and 4 form a linear pair, then we know that angle 1 and angle 4 are supplementary. And that's because linear pair gives us supplementary angles. Since the measure of angle 1 plus the measure of angle 3 equals 180 degrees, we know that angle 1 and angle 3 are supplementary. And that's by definition of supplementary angles. Well, 1 is supplementary to 4, and angle 1 is also supplementary to angle 3. So we know that angle 3 has to be congruent to angle 4. And that's because angles supplement to the same angle are congruent. We start out by writing down the given. So angle NYR and RYA form a linear pair. So angle NRY, which is this angle here, and angle RYA form a linear pair. We were also told that angle AXY and angle AXZ form a linear pair. And so that's AXY. So AXY. And AXZ. So these two form a linear pair. We were also told that angle RYA is congruent to angle AXZ. So angle RYA, this one here, is congruent to AXZ, this one here. And this was our given. We want to prove that, let's see if we can find a different color here. We want to prove that NYR, so this one here, is congruent to AXY, this one here. So since angle NYR and angle RYA form a linear pair, we know that angle NYR and angle RYA are supplementary. And that's because a linear pair gives us supplement angles. But by that same token, by that same reason, we know that angle AXY and angle AXZ also are supplementary. So looking at this, we have that RYA and AXZ are congruent, so they're basically the same angle. So we can say that angle NYA is congruent to angle AXY. And that's because angles supplement to the same angle, or congruent angles gives us that they're congruent. For the last one, it tells us that angle 1 and angle 2 are vertical angles. They give us the measure of angle 1, an expression for us, and they give us an expression for the measure of angle 2. We want to find the measure of angle 1 and measure of angle 2, and we need to justify each step. So angle 1 is congruent to angle 2, and that's because vertical angles are congruent. That gives us the measure of angle 1 equals the measure of angle 2, and that's by definition of congruence. By substitution, we can do d minus 32, which is our value for measure of angle 1, equals 175 minus 2d, which is our expression for measure of angle 2, and this was substitution. We can add 2d to both sides. And that's addition property. So we have then that 3d minus 32 equals 175, and that's substitution. We can then add 32 to both sides. And that's addition property, which gives us 3d equals 207, and that is substitution. Divide both sides by 3, and that's a division property. Gives us d equals 69, and that's by substitution. Then our final step is substitution again, because we have that the measure of angle 1 equals d minus 32, which means that it is 69 minus 32, which gives us 30 7. So measure of angle 1 equals measure of angle 2, which equals 37 degrees. And that concludes our lesson 428.